Hi guys, this is the next part of 1.12D. We already did the first two parts. I'll put the link in the description. Also, you can download this PDF. Again, the link is in the description, and if you need private tutoring, feel free to reach out. All right, so this part is mostly focused on sketching curves, so mostly important for your school. Although APs can also ask these questions, they will just give four options. Most likely, they won't ask this in as an FRQ. So on each page, we have one type of graph, and there are a couple of transformations. For example, this one has this transformation and this transformation, and then we have this transformation. So uh, we just have to, graph the transfer function. So I'm just going to pick one from each page. I have a couple of pages here, and we are just going to graph it together. So I'm going to pick question number 14, and this one involves horizontal dilation and then vertical translation. The idea is you take every point that you have over here, the corner points preferably in case of, mostly the straight lines, and then transform those points and then plot those points and then, connect those points in a likewise function, in a likewise way. So the first point, the most left point is negative 3 comma 1. Then we have negative 1 comma 1 2 3 3. Then we have 2 comma negative 1, and then we have 1 2 3 4 5 5 comma negative 1. Okay, whenever I dilate by a factor of 1 over 2, right, because this works counterintuitive, so every x coordinate will be divided by 2. So it will be negative 3 over 2, and the y coordinate is not really going to change. So negative 3 over 2 comma 1, negative 1 over 2 comma 3. This will be 1 comma negative 1, and this will be 5 over 2 comma negative 1. And then when we go down by 3, so every y coordinate should be subtracted by 3. So it will become negative 2. This will become negative 1 over 2 comma 0. This will become 1 comma negative 4. And this will become 5 over 2 comma negative 4. And we just need to graph these points carefully. So negative 3 over 2 is negative 1.5 around, which is probably somewhere here. And negative 2 is somewhere over here. So this is quadrant 3. That's the first point. Then I have negative 0.5 comma 0. So obviously negative 0.5 comma 0 is right here. Then I have 1 negative 4. That's a nice point. 1 and negative 4 is in quadrant 4. So 1 and negative 4. 1 2 3 4. There you go. 1 and negative 4. And then 5 over 2 is 2.5. 1 to 2.5. 2.5 is right here. And then negative 4 is negative 1, negative 2, negative 3, negative 4. So right here. And I'm just going to connect it using in a straight line form and in the same order. So first point to second point to third point, and then third point to fourth point. So that's how my transformed curve is going to look like. I hope this one makes sense, and I'm pretty sure you guys can try the other two questions. Let's move on to another graph with another transformation. So this time I think we are going to do, let's pick question number 18 because it has vertical dilation this time and then horizontal translation. So once again, the approach is same. I'm gonna pick these corner points. So 1, 2, 3, 4. These will suffice the requirement. And the point on the most left is going to be 1 2 3 4 negative 4 comma 1 2 3 4 negative 4 as well. This point is 2 comma 2. That's pretty nice. This point is 1 2 3 4 4 comma 0, and this point is 5 6. So 6 comma 2, 6 comma 2. Okay, first I would like to go, it doesn't really matter, you can either do vertical dilation or horizontal translation. So I'm gonna do vertical dilation first. So every y coordinate will be just multiplied by 2. So this will become negative 4 comma negative 8. This will become 2 comma 4. This will become 4 comma, well, 0 times 2 is still 0, and this will be 6 comma 4. And then I'm gonna go left by 1. So left by 1 would mean that every x coordinate is to be subtracted by 1. So this is going to look like negative 5 comma negative 8. This is going to look like 1 comma 4. This is going to look like 3 comma 0, and this will be 5 comma 4. Perfect. Now I'm gonna plot these guys. So negative 5 comma 8 is 1, 2, 3, 4, 5, negative 5 and negative, oh my goodness, really? This is going to 1, 2, 3, 4, 5, 6. Oh my God. This is going to breach apparently the grid they have given. So 1, 2, 3, 4, negative 5, 1, 2, 3, 4, 5, 6, and 7, 8. I don't know, guys. Maybe somewhere here. I hope I've not made any mistake, but that's how it looks. Then 1 comma 4 is 1, 2, 3, 4. There you go, 1 comma 4. And then 3 comma 0 is right here. And then 5 comma 4, 3, 4, 5, 5 comma 1, 2, 3, 4, 5 comma 4 is again at the same point. So I'm going to connect these two, hoping that this is as straight as it can go using my freehand drawing. So this is how the situation is going to look. That looks extremely gross, of course, but that's how it is. If I made a mistake, let me know in the comment section. Okay, then we have another type of curve now, and which one shall we pick? Well, this looks pretty interesting, you know. Yeah, I think I'm gonna go with question 20. Yeah, I'm gonna go with question 20. So the thing over here is you don't attack this question right away, because always remember that if there is a coefficient of x sitting along with the horizontal translation, so it's really important to understand why I'm asking you to take 2 as a factor, because some of my students tell me that okay, the transformation going on over here is there's a horizontal dilation by a factor of 1/2, so it becomes this, and then it is going right by 2. But that's not correct. The moment you will shift this right by 2, it will look like this, which is certainly not what is given in the question, because it will become f of 2x minus 4. So that's why I'm asking you to take 2 as a factor and now see how this is being transformed. So I think the first transformation would be there is a horizontal, sorry, when you take 2 out, there will be a 1 over here. So now the transformation will be, this is a horizontal dilation by a factor of 1 over 2. Then it goes right by 1, and then it goes down by 4. So you have to be very careful about how these things work. All right, so let's find these coordinates. So the most left coordinate is going to be negative 3 comma negative 2. And then this point will be 1 comma negative 2. 1 comma negative 2. And then this point is 1 comma 1, and then this point is 3 comma 1, and then this point is 1 2 3 4 4 comma 3. Well, that's just a point, there's no line. This point is 4 comma negative 1, and then this point is 1 2 3 4 5 6 6 comma negative 1. All right, let's do the transformations one by one. So first, horizontal dilation by 1/2, which means that every x value will be divided by 2. So this will become negative 3 over 2. And yeah, let's do it one by one. So negative 3 over 2, this will become 1 over 2. This will become 1 over 2 again. Y coordinates are just as it is. So this will become 3 over 2. This will become 2. This will become 2. And this will become 3. Now it goes right by 1, which means that obviously in every x value I'll just add 1. So this will become negative 1 over 2. And if you don't mind, I'll go down by 4 as well, because that's happening in the y coordinate. So this will become negative 6. Down by 1, sorry, right by 1 would mean that I need to add 1 here. So let's add 1 to all the x coordinates first. So this will become 3 over 2. This will also become 3 over 2. This will become 5 over 2. This will become 3. This will become 3. And this will become 4. And down by 4 will make it negative 6, will make it negative 3, will make it negative 3, will make it negative 1, will make it negative 5, will make it negative 5. So the points are going to look like negative 1/2 comma negative 6. Okay, negative 1/2 comma negative 6. 1 2 3 4 5 6. So this is somewhere over here. And then 3/2 and negative 6. 3/2 is 1 2 3 3/2. 3/2 negative 6 is right here. This should be a hole. As you can see, this one was a hole and this one is a fill circle. So that's the first piece. These two are gone. Then 1.5 comma negative 3. Now, where is 1.5 comma negative 3? 1.5 is here and negative 3 is 1 2 3 right here. This is 1.5 negative 3. One second, I think I got the 3 over 2 piece wrong, right? Yeah, I don't know what I was thinking. So 3 over 2 is 1.5, not 3.5. So 1.5 comma negative 6 will be right here. Sorry about that. Then 1.5 comma negative 3 is 1, 2, 3. There you go, right here. This is a full circle. And then 2.5 comma negative 3. So 2.5 is right here, and then negative 3, both are full circles. So there you go. Then 3 negative 1, whereas 3 negative 1, 1, 2, 3. So 3 and negative 1 is right here, 3 and negative 1. And I think this is just a single point, right? 4 comma 3. So that's just a single point that is sitting over here. Then 3 negative 5. So 3, 1, 2, 3, 4, 5. 3 negative 5, it's a whole, be advised. And then 4 negative 5. So 4 negative 5 is right here. It's a full circle. So that's how this graph looks like. If I made any mistake, just let me know in the comment section. But yeah, that's how it looks like. Then in these questions, I think I'm going to do question number 23, and this one talks about reflection. And since this is x is multiplied by a negative sign, so that's a reflection about the y-axis. So this is a reflection about the y-axis. That's the first thing, and then it is going up by 2 units. Let's write the points like as always. So this will be 1, 2, 3, 4, negative 4 comma negative 3. And then this will be negative 2 comma 2. This will be I think 2 comma 2. And then remember, there is another point which is at 2 comma negative 1. So that's just a single point, 2 comma negative 1. And then this one is 1, 2, 3, 4, 5, 5 comma 2 over here. So reflection about the y-axis will just change the sign of x, right? Whether it's plus, it becomes minus. If it's minus, it becomes plus. So this will become 4, this will become 2, this will become negative 2, this will become negative 2, and this will become negative 5. And then up by 2 is just y coordinate added by 2. So this will become this negative 1, this will become 4, this will become 4, this will become 1, this will become 4. Okay, so what is 4 comma negative 1? Where is that? 1, 2, 3, 4. 4 comma negative 1 is right here. 2 comma 4, 2 comma 1, 2, 3, 4. It's right here. Then negative 2 comma 4 is negative 2 is here, and then there you go. This is negative 2, 4. Negative 2, 1 is just a single dot. So negative 2, 1 is right here. All right, it's just a dot. And then negative 5 comma 4 is 1, 2, 3, 4, 5. Negative 5, 1, 2, 3, 4. It is still at the same point. So the way it works is I connect these 2 points using a straight line. Then I pass through the origin. Okay, I should have found the origin as well, right? Because the origin is where the semicircle passes through. So 0, 0 will become 0, and obviously reflection to y-axis is not going to change anything, and this will become 2. So 0, 2 is right here. It will make a semicircle right at this point. And remember that where the semicircle ends, that's a hole. So I'm going to make a hole over here. Well, that's a pretty big hole, but okay, you understand what I mean. Then this dot remains as it is, and then I just go straight to that line while this red dot remains as it is. So that's how the curve looks like over here. Okay, let's try one last question over here. I'm going to try question 26 because this time I have the reflection of the x-axis. That's why I chose this one. So the transformations that we have is first I have a reflection over the x-axis because of this negative. Then dilation, horizontal dilation by a factor of 2, so it becomes 1 over 2, and then it goes up by 1 because of this plus 1 over here. So let's write all the points. This is the first point, which is negative 3 comma negative 1. Then this is the bottommost point. It looks like negative 1.5, negative 1.5 comma, this is 1, 2, 3, 4, 5, negative 5 over here. then probably this point, which is 0 comma negative 1, then probably this point, which is 1.5 comma 3, 1.5 comma 3, and then probably this point, which is 1 2 3 3 comma negative 1, 3 comma negative 1 over here. Okay, reflection over the x-axis will change the sign of y. So this will become 1, this will become 5, this will become 1, this will become negative 3, and this will become 1. Horizontal dilation, dilation is horizontal. Horizontal dilation by 2 would mean that every x is divided. Every x is multiplied by 2 because it's a stretch. So every x is multiplied by 2, so this will become negative 6, this will become negative 3, this will become, well, 0, this will become 3, and this will become, I think, 6 over here when I multiply by 2. And up by 1 will just change all the y coordinates and add it by 1. So it will be negative 6 comma 2, negative 3 comma 6. This will be 0 comma 2. This will be 3 comma negative 2. And this will be, I believe, 6 comma 2 over here, right? Okay, all right, let's try to plot these guys. So negative 6 comma 2, 1 2 3 4 5 6. Negative 6 comma 2 is right here. Negative 3 comma 6, negative 3 is here. 1 2 3 4 5 6 right here. And then 0 comma 2 is right here. And then 3 comma negative 2 is 1 2 3 and 1 2 negative 2 right here. And then 6 comma 2 is 1 2 6 is, I think, the 1 2 3 4 5 6. Yeah, 6 is here. And 1 2 3 4 5 6, sorry, 6 is over here, and 2, right, 2 is right here. Okay, so this is how it's going to look. I'm gonna connect these points smoothly, so it's going to go like a curve over here. It's like a sine curve, then it's gonna come down, and then it's going to pass through this minimum, and then it will be over here. So that looks like this curve over here. Alright guys, this part ends here. I hope you liked the solutions, you understood the solutions. If you did, if you found this video helpful, please like and subscribe. Please share it with your friends. It will help my channel. And if you need private tutoring, feel free to reach out. I'll see you in the next video. Bye-bye.